Alright, this is for 2-day 1, and the way I want you to approach it is this. In 4-1, we discussed sampling. Okay, so how you picked the individuals or subjects that were going to be a part of some kind of study that you were going to do. 4.2 kind of picks up where that process leaves off. Okay, so our sampling is done. We've picked our subjects. Now what do we do? Okay, that's what this section's all about. We really have two options. Okay, you can conduct what's called an observational study, which is where you really just observe data from the individuals. You don't make any attempt to kind of influence or affect an outcome or a result. If you see the term experiment, that means two things. We essentially are trying to influence the outcome because we will impose a treatment on the individuals, and then we follow it up and we measure the response. Big difference. Okay? So in this first question where we're saying, is this an observational study or an experiment, that's what you're looking for. Okay? And that whole description about this situation with the amount of time spent in child care and displaying more assertive, disobedient, or aggressive behavior, which is this? And the answer is that it's an observational study. And I could justify it by saying no treatments were imposed on the kids. To say that it's an experiment, that would have to happen. And it didn't. The explanatory variable would be the amount of time spent in childcare. You can still think of that like your x variable. And then your response, we'll just call it the amount of aggressive behavior, or the extent of aggressive behavior. And this is a huge, huge thing with observational studies and experiments, because we still have to kind of address cause and effect, and by the end of this lesson we pretty much will, okay? But here the answer is no, and this is something you can always go by. No matter how tempting it is, if you recognize that the circumstance is an observational study, or that's what a problem is describing, we can under no circumstances conclude cause and effect. Sometimes we just call that causation. From an observational study. Experiments potentially can. That's one of the big takeaways you want from this slide. Experiments potentially can, observational studies don't. Here's actually one of the concerns that we have with observational studies. lurking or confounding variables. They sound really similar, and it's kind of like a lurking variable we're worried about, and then a confounding is kind of like our fears are confirmed, and we know there's kind of an issue with our study. Okay, here's the way you should think about it in the most straightforward terms possible. Okay, a lurking variable could be associated with our response variable. It could be. Okay? If you believe that a variable is confounding, you would have to show that it's associated with x and with y. Okay? Be associated with x and with y. So this problem down below basically is describing what we would call so I can get the whole thing on there. Variables that are confounding. Okay, so it's saying, is the binge drinking causing the lower grades? Well, no, the confounding variable is likely academic motivation. Okay, there's a very likely scenario that the amount of time the student is spending partying, basically, is leading to less studying. And then less studying is leading to the lower grades. Okay? So notice in my explanation, because the extent of drinking was the explanatory and the poor academic performance was the response, I could make a case that not studying is related to both. Again, the student is spending their time partying, not studying. Okay, there's a relationship there. That is, partying goes up, studying goes down. I've connected it with x, and then as studying goes down, grades go down. Okay, but that's what you have to do if you want to classify it as confounding. All right, here's some good vocabulary to know. I'm not going to go too far with factors and levels. Those are almost like categories of treatments. But if you identify that a problem is an experiment, you should be able to identify these things. Okay, the experimental units are the individuals that the treatments are applied to. Okay, if they're people, we usually call them subjects, but they don't have to be people. Okay, but then, like the intervention that we're making to try to influence the response variable, we call that a treatment. Okay, a lot of times treatments have like these different categories, like that's what we're getting into with levels and factors. There, without an example, I don't want to talk about those two. Treatments and experimental units are the way more important thing from this slide. All right, take a minute to read up on this one if you need to. So experimental units can be kind of funny. It's really tempting to say that it's the people, but there could be multiple cases within one house. So really the experimental unit is the household, because we're not going to mix and match treatments. Every single household, is, if there were multiple cases, is going to get the same one. And then really what we're measuring is, if there were more than one case, is that household lice-free. Okay, is the household lice-free? We have two explanatory variables, ivermectin and malathion. Because there's your variability as to, which of those two did they get. The response variable, pretty straightforward. Presence of head lice. Sounds like the study is measuring for that particular household. Did it get rid of it or did it not? Okay. And those two explanatory variables, those are also what we would call our treatments. All right, this is getting into some other elements of an experiment, because let's kind of recap. If we just gather data, you've got an observational study. You impose treatments and measure the response, you've got yourself an experiment. We're kind of building towards here how we put together what we'll call a well-designed experiment. Okay, what this situation is describing with the caffeine, and the reason the answer is no, we'd say the description lacks control. Okay, this goes back to our lurking variables. We should be making some attempt to control them. In this case, the lurking variable would be sugar, not the caffeine, right? And there was no effort made to make sure that those that got the treatment, the soda, got caffeine, but got it without any other ingredient that could potentially affect their heart rate. Okay? So would it be the sugar that's causing the bump in heart rate or the caffeine? Could it be both? Without control and removing the presence of sugar, we can't be sure. And that's what we're saying when it lacks control. Now this is basically getting into aspect number 2 of a well-designed experiment. We'll summarize these in a couple of slides. But it should be random. Okay? And we go back to hat theory. Write each of their names on separate pieces of paper. Put them all in a hat. Select one. Record it. Put it back. And then repeat the process until we have 15 unique names. The 15 students selected are the caffeine group, and then the other 15 are what we'll call the control group. Right, they wouldn't get any caffeine, so we could just see what's going on with their heart rate with no treatment. Okay, so this really illustrates two things. You'd have a control group, and now you've got the random assignment. Those are two elements that are moving us closer to an experiment that we would call well-designed. All right, here gives another one. Okay, and again, this is with the randomness of the assignment. I'm going to put a little diagram with this one. Here's what this should look like. It says we have 3 treatment groups. So we start with our 90 subjects. Okay, the very first thing that has to happen with them is what we would call random assignment. They have one of three places they need to go. We'll split them up 30, 30, 30. We need 30 individuals to go to control. We need 30 to be in what they're calling the low carb group. And we need 30 more to be in the low fat group. That's where they would get their treatment, and then this is always the finish to our diagram like this, because this is where an experiment would end. We need to compare results. Okay, now I should have a description with this. Okay? Put all 90 names on separate pieces of paper. And put them in a hat. Now I got 3 different ones to do, so I'm going to be a little bit more straightforward here. So I'm just going to say put them all in a hat. And randomly select and randomly select 30 names. Then continue. And select 30 more that are all different from the first 30. The first 30 they're what we'll call the caffeine group. Whoops. I gotta back up here. I'm still thinking about caffeine. We switched studies. So really we can pick whichever we want here. Let's say the first 30 are the low fat group. The second 30 we'll make them the low carb group. And if you think about it, I should have 30 names that are still left in the hat. I'll call them the 30 remaining names are the control group. Now, I ran out of room here. And obviously, there's a lot of writing that goes with this one. But the one thing I should add to this is, to finish off the experiment, that we should apply the treatments to all the groups, and then we should measure the response. Okay? That I didn't add to this, but that should be there. Okay? That should absolutely be there. This is back on the caffeine. We had already hit on two of these, randomness and control. Okay? Replication is the third. Do a well-designed experiment. And really all that means is for it to be well-designed, you should be able to do it with lots and lots of subjects. The bigger the sample size, the better. So that's the third thing. You know, replication, randomization, that was about the assignment of treatments, how I described it with hat theory, and then, of course, control. Oh, we're going to skip over that slide. So really what we're after here, and why we do the random assignment, is if we're splitting everybody up into these groups, we want them to be as similar as possible. Okay? Just think if I didn't do it and like I had an experiment and somehow like I didn't do random assignment and it worked out that all males got one treatment and all females got the other. That's not good, right? I want to create two groups that are as similar as possible. So if there is kind of any variability in the responses, they should be about the same between the two groups. Okay, so the one experiment design we've already looked at, we would say that that is completely random. Okay, there are two more that I'm going to show you in the days ahead, but this is one of the most important ones, right? And completely random just takes everybody you have, puts them in a hat, and you do your hat theory thing till everybody is randomly put in the group that you want them in. So this is a pretty similar diagram to the one that I drew on that other slide. You split them up into your groups, they get their treatments. Now remember, a diagram like this should have an explanation, and this is kind of a good reminder. Again, even though I ran out of space, it should finish with comparing results. Okay? It should finish with comparing results, because that's when the experiment is kind of done. Blind and double blind. You know, if an experiment is blind, the subjects don't know what treatment they're getting. Double blind, those administering the treatments also don't know. But here, let's finish with this, because this is interesting. We've actually now covered enough to talk about cause and effect. Okay? So that's kind of number one, is the association you observe has to be statistically significant. In other words, it's got to be big. It's got to be really strong. We'll talk about how strong and how we'd measure that. Okay? Number two, that association has to be observed from an experiment. Number three, that experiment has to be well designed. Okay? If you can meet all three, you see a really strong association, and you got it from an experiment. So you imposed treatments and you measured the response, right? And you did the whole well-designed thing. You had randomness, you had control, and you did it with a really, really good sample size, right? That's the replication. If you meet all three of those, now you could establish cause and effect between your X and Y variable.